Also, the talk is also co-written by Aziz, our chief architect, who couldn't make it, so I present, but credits also go to him. So if you want to talk to him, find him on LinkedIn. Okay, so basically it goes about monoliths to microservices, and first a bit about Dubizzle. I think everybody in Dubai knows that. We are a pretty big classified site, real estate, cars, jobs, everything, you know. We still run our beloved monolith, which is now around 10 years old. We replace him bit by bit with services to make it to the brave new world. Also, we are one in the 5 biggest sites in the region, including Facebook and Google. So we got quite a bit of traffic between monoliths and the services. So just switch one off, move to the other one is not so easy if you don't want to lose a lot of users. And also, like I said, we're still in the journey of replacing it. We haven't gotten rid of it completely. And if somebody is interested in this journey, taking part, CVs can go to hireme@dubizzle.com. Okay, and now a bit about it. Microservices are all good, all nice, all the rage about, but before you join or go on this journey, think about if you really need to do it. Not because I don't like it, I like it a lot, but monoliths are well understood. Basically, everybody knows how to use it. It's one application server, one layer of caching, one database, perfect, fine. If you go to microservices, you get the same stuff, but for each service. So complexity goes a bit through the roof. With 10 services, it's like 10 applications which you have to deploy, monitor, scale, test, 10 caching layers for each application, and 10 data stores if you do it right. Distribution is not free. Basically, before it was all internal syscalls on a machine with memory. Super fast, super nice, no network. Distributed services have network latencies, unreliable networks, nodes going up and down, so you have to factor it in. And one of the things we discovered is also that the organization structure must fit the model. I code it on the next slide, because at some point you wonder why. There's a guy called Conway, I forgot the first name, and he formalized Conway's law, which basically organization designing systems are bound to design system which reflects our communication structure. So if you think about software engineering, so if you have a big room, like we're all engineers in one company, imagine that, and if everybody talks to everybody and everybody can touch everything, so I can basically make any change I want without telling other people or telling other people. So it gets a bit chaotic over time, leading to maybe single files classes with 10,000 lines of code, which are difficult to maintain, let's say it like this. Then where are boundaries? What should I do? What can I do? Where do you need to ask people to do it for me? And think about KPIs for a company if you want to change something, but you have to break somebody else's stuff. Is it okay? Is it not okay? What to do? So we need a bit of clear separations at some point. Then over time, we do the services actually for quite a while. We thought, like, let's formalize some guiding principle to say everybody has a framework. It's not set in stone, but just we use it with care. So it's 10 principle, or 11. So first is low coupling, high cohesion. Basically, before we had an API with a service talking another service to another service. Gives real nice separation. Operation is still easy, but basically you don't win much, as developing it is easy, but you have many dependencies, which we want to do away with. So you don't gain stability, but years of development. But in the end, we said, like, let's not do this again. High cohesion is basically you have one service which can talk to others, but that's it. We also said no service can depend on any other service for uptime, functional data availability. Let me explain with some exceptions. First, we said, for example, in Dubizzle we have categories, we have users, and we said you should not depend on basically a user service to know what a user can do. So we have in each service or microservice, you have to have caching for information you need, but is held or maintained by somebody else's source of truth. Whereas that comes a complexity which goes up by number of services. Also, do exceptions. Basically, if you have a website and for certain things you need to log in, if authentication doesn't work, then it just doesn't work. So there's an exception to the golden rule, which is fine for everybody, it's accepted. And just say, as long as browsing and other general stuff works, if authentication is gone, then we just live with it. Next thing is between services, don't do distributed transactions. I know everybody's aware there are distributed transactions in the system or in the world, but it's never been a really great idea, never really worked for anybody on big scale, and just causes problems. So we just said, let's not do this thing. Our principle number 4 is very specific to us. We have 4 verticals, basically property, cars, jobs, and general classified. And we just said, whatever we do in one can have no impact to another one. Can apply to many other company areas. For example, if you look at booking, flights reservation still have to work even if hotel reservation is broken. So if you build it, just think, what's the company doing, what's the context, and then make clear cuts between it. Goes against Conway's law, org structure should follow what you want to build. Number 5 is a bounded context, which is my favorite one actually. Bounded context is not in, here's an API, CRUD, this is how it goes. It's more, what do you want to achieve? What's the business case for a service? And then you think about it, how it fits. And it can have one API or multiple, doesn't matter. It's just one service covers all this case. Yeah, we come back to that later. Then we have 5 more. Choreography over orchestration. An orchestra is basically a dirigent in the front, and that first you do this, afterwards something else, and then you do a third task. Choreography is basically, you have maybe a bus, everybody listens to it, and if there's a message to a certain type, everybody knows what to do about it. So no central point of failure, no dirigent guiding. It's just, it works by everybody knows what to do. Number 7, events are first-class citizen. This is a bit misunderstood. I have a bit more detail afterwards. It's basically, think about event sourcing, and the events should be able to tell you the state of the system at any point of time and deal as, or be source of truth if you need to. Then analytics and logs are the only source of debugging information. As before, usually you have develop an Amazon when you run in a data center. So you have developer accounts, staging accounts, and production accounts. And depending on size of your organization, you might have internal audits and say limit you to say, okay, developer, everyone can have access. Staging, just make sure there's no private information of any users. But on production, where it's all the data, all the credentials, then you have to limit the access. But as applications break, sometimes you need a bit more debugging information as monitoring systems can give you. So you said, take a lot of care with analytics and monitoring so that you can find out what's broken without SSHing into a service on some machine. That's quite important, actually. Then rate limits, privacy, authentication, authorization is one of the base pillars. Monolith, simple monitoring, traffic goes in, response go out, all fine. With services, if after a certain size, it's hard to figure out what's going on. So basically, which service talks to who, where is the source of the information, what should be in there, what not. If something breaks, where do we find out why it's broken? It's most of the time not the service which doesn't stop which stops working. It's more something else which broke on the way giving data. So this is actually quite important to figure out what needs to be fixed. And then the last one is also every service needs to be auto-deployable, updatable. Basically what Steven presented in the Kubernetes talk about container platforms. It's basically if you have a couple hundred services, it cannot be done manually anymore. So it needs to be all automatic. Push code to repo, gets tested, deployed to stage, tested again with a bit more features, and then goes to production one after another. Okay, then some details is just not really in tech, it's more the bounded context. As said, every service must have its bounded context. And then some people think it should be the same entity, and just random examples, basically if you have somewhere a product service and some other service handles product, it can have the same name, but actually the attributes you need in each bounded context are different. So even if things have the same name, it does not need to be the same in that way. A service or microservice should handle the complete bounded context, and actually if you're in doubt, like say, we design a system, I don't know, leave it bigger. So we found if you build microservices and want to run them, if it's too small, at some point you say, it's not really right, and you have to join them, it's complicated, to say at least. If it's just one bigger service and say, okay, actually we can split it down into smaller pieces, splitting things is fairly easy. Compared to joining them again, can be done in a day actually, because code is there, just copy paste the code, remove, deploy both services, done. That's actually pretty simple. And then another thing we found is there are two trains of thought. One is share everything or share nothing for classes, code, and so on. Basically, share nothing makes life easier. Think about one service or no service should depend on another one or should be affected. So if I want to make changes and I have to change public entities, that would break a lot of things. So better share nothing, and even if it's copy-paste for getting a starting point, it's easier to deal with it. Okay, then events are first-class citizen. If you look at events, everybody said in monolith you have one database, has all the state, you know what's the current status of your application. Once you go into microservices, everything, or most people choose a bus. And if you run everything over a bus, then state is distributed. So it's not always easy to figure out what's the state of your application between different services, because you have no central source of truth. Maybe a BI system where all data goes, but that doesn't count. So event should be treated as source of truth, and you should be able to replicate any state of the system only from events. Netflix had a chat about use NumPy smart endpoints, which basically, if you look at your event system bus, which needs to run or power all the things, then the bus can be really simple as a message queue without any logic, but the counting of messages, recording of what you got, should be at the service level and not on the bus. For example, Kafka provides the ability to just resend messages RabbitMQ2, but then where does the service or the bus knows what to resend? So put the logic in the service and just store everything which you have received, what you have sent out again to the bus, which the state and the data. And if you can, make everything idempotent, which basically can also keep another log of what you worked on, what the state of it is. One note here, in general, think, hey, let's just use what we know. Use a MySQL, PostgreSQL, it's general purpose data store. But actually, for events, don't. For events, it's way easier to say, if you look at the use case, we have high write load. So we write a lot of events to the event store. And the chances of we just need to read them again and retransmit are fairly low. So event stores should go on the right side, which basically means something like Amazon Dynamo, Cassandra, which were actually invented to just support heavy write loads and then read when needed. And yeah, basically, again, for complexity, monoliths were easy. Everybody knows one data store, one caching layer, one set of application server. No service depends on each other, or services depending is what you get if it doesn't work so well in the beginning, or if, yeah, basically a lot more to monitor, configure, set it up. If you use a message bus or APIs for internal communication, then you still have to worry about compatibility. As said, no service can break each other, but if I do an update, what happens? Can the others read my messages? Does it change? We've been there, figured it out, but it's also not so nice if you go in the beginning. Systems can help. Afro does provide schemas that you can only send certain valid messages on a bus. That helps a lot, and they have technologies or techniques to migrate messages from one schema to another one. That actually makes your life easier. Then basically also monitor not only services, also the event bus. How many messages are going in on average, day by day, peak hours, non-peak hours. Compare them to figure out what's happening. If there's something broken on producing, consuming, which gives just an indication if services work or just scaling policies are not right. So there's one more thing in the middle you have to monitor. And just as I said before about events, just be prepared to replace them when needed. Events are transactions, so could mean revenue. So in the end, you have to allow to lose any of them. Okay, and okay.
Services can serve other services.
Sorry?
Services can serve other services as an aspect.
In code or as just request response?
I'm trying to link that to the guidelines. I need just to give boundaries to what you are saying.
Basically, okay, Dubizzle. We have categories. Categories are property for rent, property for sale, cars, and the different brands. And that can be one service. Is it a business case? Sort of. Others depend on it. But so I would do requests to it to say, okay, give me the latest category tree. But then in a different service, I would cache it. What we have done is basically we have one initial set of categories in each service, which are just hardcore deployed in case category does not work. So you can still bring up the site and run it. But then whenever we do a change, the category service would send it to an event bus as a message. Then everybody takes this response from this message from the bus and caches it locally. So one service is a source of truth. It does not break other ones. We have clear separation. We just deliver, in case it does not work, you deliver a static JSON file to bring the service up in case the first one does not work. But then every change goes through the event bus and we cache it locally in each service. More or less clear? Let's talk afterward about it. I can explain it and maybe find a sheet of paper and I can draw a wonderful picture. I made slide last night, so I didn't have time to make pictures, but I can explain it quite well. References, it's just a quick one because we put it live. The Tiger team in Denmark written a wonderful 6-article series about bounded context. I can only recommend that. Then consumer-driven contract is basically contract-driven development for APIs and messages, quite helpful. How to design a good API by Bluch, and then basically last one is Building Microservices by Sam Newman. It's a book from Riley. It's quite good if you know it already. It doesn't bring so much news, but it goes also about testing. Also, we put the slides live so that you have it afterwards. Okay. Okay, I think I was fairly quick. If anybody is interested in joining this journey, hire@dubizzle.com is the email address to go or to send your CV to. Thanks. That's all. Questions? I will pick up with you afterwards directly in a one-on-one talk to get a little session. Any more questions or pizzas? Okay.
Thanks
cool.
for coming.
Thank you.
Yeah, that door.